Good morning, everybody. I just want to give you guys a quick update on how to do this real fast. So you should see the momentum lab here. The first thing you should do is have these three on your chart that look the same exact way. You should just click on the center of mass and the momentum diagram so you can see both of these. I like to make my chart look like this so I can see the momentum arrows as we go. Now you should be clicking the More Data button down here too, so you have your chart looking the same as the chart over here. Now what you gotta do is predict what will happen when you before and after the collision. What would each object happen? What would they do? And all that fun stuff. So the first thing you do is copy down the mass. The mass for mass 1, mass subscript 1 here. Follow what ball 1 says. So this is going to be 0.5. The velocity should be 1.0 as listed right here under the velocity section. And the momentum, which is P is the momentum, has a momentum of 0.50. Now mass of all 2 is what? 1.50. Velocity, we don't care about position, remember, we're going to care about velocity next. The velocity of the second ball is going to be 0. And the momentum is going to be, as it says over here, 0 as well. Now for the mass, we're going to care about the ball 1, because that one has a velocity we can solve for. Notice we're going to have a little bit of prediction powers, because we're going to be predicting these last 4. So now we have to think about what's going to happen to velocity as it hits. Now, if you ever collided two objects, if you have two rolling objects available to you, try rolling together, and you should see what happens to the velocity. It's either going to go up or down, and we're going to see what happens. So for mass 1, I'm going to predict that the velocity is going to go up. I'm going to say it goes up by a whole meter per second. It's going to go hit it and go faster. Now, momentums is what you should know from the law of conservation of momentum and what would happen there. So we can predict that saying like it's going to add up. So let's say knowing the law of conservation of momentum says you have the same momentum when you start as you do when you end. So I'm going to say that and 1.0. Say that that's the thing. So let's now actually run the lab. So all you have to do is to press play on here and record what happens actually. So hit play. And after it collides, you can let it run for a couple more seconds or you can just stop it. So now let's see what changed. Did our mass change? No. Our mass stayed the same. Did our velocity change for velocity 1? Yes, it did. So what happened to the mass? The mass stayed the same. Oop, that's the momentum. What happened with the momentum? Well, it dropped in half. Except it's going in the opposite direction. What happened to the mass of the second one? Stayed the same. The velocity of the second one changed to being 0.5 instead of 0. And the momentum went up to 0.75. Now again, what happened as our final, if we look at our mass 1, we have, again, our mass of 0.1. What happened to our velocity? Well, it went down in half to 0.5. What happened to momentum of 1? Well, we went down to 0.25, and our final for momentum 2 went to 0.75. Now what we're going to have to do here is we're going to look at the stuff down here. It says momentum initials. So we're going to go back to our stuff here, and we're going to look at in beforehand and afterhand what happened. So we said beforehand, we had, I'll make sure you put the negative sign here, we had as P2, 0.50. And for P2, we had 0. So it's 0.50 plus 0, well, that gives you 0.50. Now, for the final, what do we get? Well, we had a negative 0.25 momentum for the first mass and a positive 0.75 as the second momentum. Now, what do you get when you do 0.75 minus 0.25? Well, you should get 0.50. Now, do our momentums match up? Well, they should. We both got 50 for each of them, thus making law of momentum the same. Now, for the second part down here, the second experiment, you're going to be doing the same exact thing as we did above, except you're going to be changing either the mass here. You're going to make it like this mass of 500 and make it a huge mass. And play it. So you have to see this huge mass come along and kick out the second one. You can make it a very, very, very tiny mass and make it go and hit the object and see what happens. You can change the velocity of it and see what happens. Or you can see what happens if you change ball 2. So we're going to move this position to 1 so we can see it again. This back to 1. And we can say this velocity is going to change. What happens if this one has a velocity of 1? Make sure it's pointing the opposite direction. And what happened then? If two things collide, what would happen? Notice the momentum chart down here of what happens. So that's what I want you guys to do for the second part there. So essentially taking the numbers here and plugging them in here and following the example that I listed above. If you have any further questions, please feel free to email me or join any of the meetings. Feel free. I will answer questions throughout the night. Thank you very much and have a great night.